Over the next few years, consumers in the United States have an opportunity to curb their energy consumption in their homes and save their hard-earned money during the process. This is possible due to the Inflation Reduction Act, passed by Congress in 2023. The U.S. Congress allocated over $1 trillion to energize the renewable energy industry by investing in energy supply chains, emissions reduction, consumer energy savings, and clean energy jobs. This is in addition to the $1.8 trillion passed in 2017 as part of the Clean Energy for America Act. A sizable amount of these two massive budgets is allocated towards energy efficiency in the residential and small business sectors. Some of the incentives include tax credits of up to $7,500 for new and up to $4,000 for used electric vehicles, as well as incentives for installation of home charging units. Tax credits to cover up to 30% of solar panel installation costs. Rebates that can cover up to 100% of the cost of purchasing and installing a new electric heat pump dryer. These units are more efficient than conventional electric dryers and gas dryers. Rebates that can cover up to 100% of the cost of electric stoves, cooktops, ranges, and ovens, as well as tax credits and rebates to cover the cost of heat pumps for heating and cooling and water heaters. Heat pumps provide more efficient heating and cooling than furnaces and air conditioners. They are also 2 to 3 times more energy efficient than conventional water heaters. Additional incentives include up to 30% credit for the purchase and installation costs of solar water heaters, battery storage systems, small wind turbines, and geothermal heat pumps. According to a 2022 report by the Energy Information Administration, more than half of energy use in the residential sector is for heating and air conditioning. Therefore, the focus of this video will be on achieving energy efficiency in the heating and cooling of our homes and saving on our utility bills. This can be accomplished in 2 different ways: passive solar design and active solar design. Active solar design requires large upfront costs such as solar panels, geothermal heat pumps, and small-scale wind turbines, and we will cover this section in our upcoming video. This video will focus on achieving energy efficiency with minimal upfront costs using a method known as passive solar design. This method is implemented using some basic knowledge of earth science combined with time-tested techniques and affordable products. The upfront cost is low, and the impact is immediate and long-lasting. Passive solar design incorporates building orientation, material selection, insulation, and weatherization methods to reduce energy consumption and keep our homes and businesses warmer in the winter and cooler in the summer. During the summer seasons, our efforts are concentrated on blocking the sun's energy to keep our homes cool. This is known as passive solar cooling. One of the simplest, most affordable, and most effective ways of accomplishing the task is using overhangs. Since the sun's path follows a high arc during summer, roof overhangs are very effective in blocking the sun's rays. During winter, when the sun's heat is needed, overhangs do not pose a problem since the sun follows a lower arc path. So natural light and heat can reach our homes. Blinds are also another simple and time-tested product that contribute to a more regulated interior temperature. Finally, trees and plants that thrive in summer and lose their leaves in winter are a great addition to the energy savings package. They block out direct sunlight in the warmer months while allowing sunlight to reach our homes in winter. It's a smart choice for boosting both energy efficiency and visual appeal. The most passively effective means of keeping our homes cool during hot summer days is by using the right building materials during new construction or when modifying existing buildings. Building materials with high thermal mass, which is the capacity to absorb energy, contribute to a cooler interior temperature because they absorb the sun's energy rather than transferring it to the interior. The absorbed energy is eventually released into the interior hours later in the evening or at night, providing a warmer interior when temperatures would have dropped. These building materials help us regulate interior temperature by keeping it cool during the day and warm in the evening when needed. Thermal mass is formulated using heat capacity and density. Heat capacity is the amount of heat energy required to change the temperature of an object. For example, it takes a lot of heat energy to change the temperature of concrete or clay compared to metal. Therefore, building blocks made from concrete or clay have higher heat capacity than metal and are more desirable for passive solar design. In addition, Their compact mass or density allows them to absorb much of the incoming heat. These materials are costly, so they are normally applied during new construction. However, they can be applied for flooring of existing building at a more reasonable cost for energy efficiency. When the sun's energy enters a living space through doors or windows, the energy strikes the floor at an angle. Depending on the floor material, the energy will either be absorbed or dispersed into the home. Tiles made of earthy material, such as clay or concrete, are the preferred choices because they have an excellent thermal mass and can absorb the heat that enters the home and help keep the space cool during the day. The absorbed heat is gradually released during the evening when most needed. Building materials for passive solar design are ranked according to their thermal mass. The higher the ranking, the more desirable the material. Material selection is a method that has been passed down for generations. For centuries, many cultures around the world have used materials with high thermal mass, mainly earthy materials, for similar cooling purposes. Winter brings its own set of challenges. This time, the goal for energy efficiency is to allow as much of the sun's energy as possible into our homes. This is accomplished using passive solar heating, which is a method of orientating openings, such as doors, windows, and skylights, to face the sun. Homes reoriented toward the sun have proven to save between 10% and 20%, and the IRA provides tax breaks and rebates for upgrades of exterior windows, doors, and skylights. Once passive solar design is implemented, the next task is to limit the amount of air that flows in and out of the home and keep the indoor temperature as consistent as possible. This is accomplished using insulation, which helps reduce heating and cooling costs. Insulation can be applied either during new construction or on existing buildings. Insulation levels are specified by the R value, which is a measure of the insulation's ability to resist heat flow. The higher the R value, the better the thermal performance. The attic is the most effective place for proper insulation. Since the sun's pathway is directly overhead during summer, insulation in the attic serves as the last defense between the heat-stricken roof material and the living space below. Of course, using earthy roof tiles reduces the amount of heat transferred from the sun into the attic below. The less heat transferred to the attic, the less insulation is needed. Similar insulation measures also need to be implemented on the outside perimeter walls for further efficiency and savings. Finally, detecting and measuring air leakage is the last step to an energy-efficient home. Air leakage occurs when outside air enters, and interior heated or air-conditioned air leaves the home through cracks and openings. Detection can be accomplished visually or with measuring devices. Once air leak areas are identified, caulking and weather stripping are two simple and effective air sealing techniques that offer quick returns on investment. Caulking is used for cracks and openings between stationary house components, such as a round door and window frames. On the other hand, weather stripping is used to seal components that move, such as doors and operable windows. After all, windows can be responsible for 25 to 30% of heating and cooling energy use, and doors can leak significant amounts of energy as well. Again, the IRA provides financial incentives for these upgrades. Today, many architects and home builders are incorporating time-tested methods of orientation and material selection, along with modern construction materials, into modern home designs to reduce energy consumption and expenses. The U.S. Department of Energy estimates that over 2 million energy-efficient new homes and apartments, known as Energy Star certified, have been built to date. Over 2,800 builders, developers, and manufactured housing plants are Energy Star partners, including the nation's 20 largest home builders. Existing buildings can also meet Energy Star certification by adding efficiency products such as insulation, windows, and doors. In our upcoming video, we will look at energy efficiency and savings using active solar design, which includes solar panels, ground geothermal, small-scale turbines, water heaters, and others, including Energy Star appliances and LEDs.